Now that we have the numerical solution to our mathematical model based on the Euler-Bernoulli beam theory, let's move to post-processing. And before I get into answers, I want to take a minute to situate ourselves within the framework of what's under the black box. So we provided answers with the mathematical model, and then we provided a mesh on which answers was able to generate numerical solution, and it now has selected variables at selected points. And everything, so when we look at results in post-processing, everything is generated. All those results are generated from these selected variables at selected points. Going to answers, I'll highlight solution in the tree, and the first thing we look at is a deformation, and we have an intuitive sense of how things should deform when loads are applied. So I like to look at deformation first before looking at things like stresses, which are more abstract. So highlight solution in the tree, select deformation total, and then just right click and say evaluate all results. You can click solve, but I like to remind myself that this is post-processing, so this is just the evaluate all results is, it's not going to, it just means that it's a pure post-processing step. Okay, so we get this, and I'll zoom, I'll kind of manipulate the view a little bit over here using the middle mouse button. And let me go here, and I'll say show undeformed wireframe. So that's our the midline before deformation, and that's a midline after deformation. And if I look at the amount of deformation, it's and let's compare that to the hand calc. So it's probably, this is in meters. Let me change the units to millimeters, and it turns out to be around 5.1 millimeters, so this compares, so in the hand calc we got 5.10 millimeters. So that's close enough, and we can go and investigate further this comparison in the verification step. But that order, the important thing is to check if that order of magnitude makes sense, and it does. And also, we know that when we apply a force over here, it should move down. So again, that seems to be, check with our intuition. And over here, we have, the displacement seems to be 0, which is encouraging. We need to check the slope. I'll get to that in a second. And so so let's check the slope. For that, what I'd like to do, so this is exaggerated by a factor of 44. So to true scale, you can hardly see the deformation. And the auto scale that answers gives you is 44. So that's the deformation exaggerated by 44 times. I'm going to super exaggerate it. And this is very useful to figure out, the deformation and check boundary conditions and so on. So I'll do that. And this is a little bit concerning because here the slope is not 0. So let me explain that. So we have, at this node we have UI1, and we have UI2 and UI3. So this is equal to UI2, and that's equal to UI3. And UI1 is 0, as we expect. But remember, we also have, the rotation of the cross-section. So we have theta z at that location should be equal to 0. And that's equal to duy by dx at node 1. And that means that, it should be like this, the deformation, whereas it's not. So, from this visualization, it looks like this boundary condition is not satisfied. And this troubled me at first. And so I went and did, a bunch of checks and convinced myself that It's actually, it's just it's a purely visualization issue. The solver does it right, but when visualizing the graphics, it's not done right. So it's ignoring the slope and just using these values to show you the deformed shape. And you'll see that as you refine the mesh, you'll get more of a smooth variation. And you can also go here, View, and turn on thick shells and beams. And all this is doing is, it's wrapping the cross section around the deformed midline. And again, we see, there's the slope discontinuity, creates this kink, which is non-physical, and so that's a purely visualization thing. So I'll just turn off thick shells and beams, okay? And then if you want to take a snapshot of this, you can do it in two ways. You can go here, let's see, somewhere over here. Yes, this one. You can say image to file. Sometimes it works, sometimes it doesn't. The workaround, if it doesn't work, is to use the snipping tool in Windows. So if you type in snip, it brings up the snipping tool, and you can basically say which where you want to snip and then save it. I'm not going to do that in the interest of time. No? Okay. So that's the first step in post-processing. Let's move on to other things in post-processing, and before that, save your project.